Section 12, I'm doing the quotes thing, Section 12, Lesson 4, Part 3. We're going to be looking at some long division with polynomials. We'll start with a review from 3rd grade. How fun is that? So I'm going to zip ahead to polynomial division. And the first thing we're going to do is use the 3rd grade strategy. Now, I know from my kids being in school, they were teaching you new and different ways of doing division. So I want to verify that you know how to do this kind of division, or we'll find a way to make it make sense. Now, if you'll also notice, this is +7. In your version, it may be a different number, and I don't remember what number it is, but it should be +7. So you're going to want to make that adjustment. So let's think about how we would do long division using numbers with this. You would put 5, I call it outside the house. I wasn't an elementary school teacher, so I don't know how they do this. And then put the number on top here, 3, 4, 2, 6, 5. And you might immediately say, oh, we know 5 goes in evenly because of that 5 at the end, which is really cool. There are strategies of determining if a number is a factor, that is, if it goes in evenly. So the process is, of course, to think in terms of 34. What number times 5 gives you a number less than but close to 34? And you might say, oh, that would be 6, because 6 times 5 is 30. Then the next step is absolutely key to your success in polynomial division. You'd say, what do you do to that 30? You subtract it. And I'm going to put this really bright pink because we're going to need to do the same thing with polynomial division. And it's so easy to forget. So when we subtract 34 minus 30 gives me 4, and I'll bring down the 2. So something times 5 gives you a number close to but less than 42. And you might say, oh, I know what that is. It's going to be an 8. I've kind of not given myself a lot of space there. 8 times 5 is 40. So I'll take 8 times 5 is 40. Then that all-important key step is to subtract that 40. 42 minus 40 gives you 2. And notice we brought down that 2, and we're going to bring down this 6. And you might say now something times 5 gives you something less than 26. You guys get the pattern. So I get 25, and now I'm going to subtract, and I get 1, and I bring down the 5, 15, and you might say 3. So the fact that there was, 3 times 5 is 15, and I subtract and I get a 0 there. So the fact that there's no remainder means that 5 is a factor of 3, 4, 2, 6, 5. 34,265. You can also say that 5 times, look at where I'm going, 6, 8, 5, 3, is equal to 34,265. That multiplication statement is really key. We're going to do the same process with the division using a polynomial, that I put x plus 1 here outside the house, and then inside the house I'm going to put this expression. 3x cubed plus x squared plus 5x plus 7. And now I'm going to do the same kind of thinking. I want to think what number or what expression times x gives me 3x cubed. And you may say, oh, that's going to be 3x squared. So now the thing is, I need to distribute that 3x squared to each item there. So I might get 3x cubed here, but I'm also going to get 3x squared times 1, or positive plus 3x squared. So now this is the key step that's so easy to forget. I'm going to subtract the entire expression. Now it might be easy to remember 3x cubed minus 3x cubed, but here I want to take x squared minus 3x squared, so I would get negative 2x squared. I'm going to bring down the 5x. And I go back to thinking in terms of what times x gives negative 2x squared. And you might say, well, that's easy, negative 2x. So now let's distribute the negative 2x. Negative 2x times x gives you negative 2x squared. Thank goodness, when I subtract, that will disappear. But I do need to distribute. Negative 2x times 1, negative 2x. So now I'm going to subtract the entire expression. And when I subtract the entire expression, I'm going to get, well, that'll disappear because it's negative 2x squared minus the negatives. It's like plus. So this is 5x minus a negative 2x. So that's going to be positive 5x plus 2x will give me 7x. And now I'll bring down the 7 plus 7. So I want to think in terms of something times x gives me 7x, nice, plus 7. 7 times x is 7x. I distribute the 7 plus 7, and indeed when I subtract, I get 0. Let me put in pink the subtraction. What do you guess is the most common thing for people to forget? Subtracting that second term there. The fact that there's no remainder means that x plus 1 is a factor of 3x to the cubed, 3x cubed plus x squared plus 5x plus 7. And indeed, I could write a multiplication statement that says x plus 1 times, and look where I'm going to go up to the top, just like I went up to the top over here, times 3x squared minus 2x plus 7 is going to be equal to 3x cubed plus x squared plus 5x plus 7. Okay, check. A lot of values there, a lot of x's, a lot of numbers. Check to be sure that that idea, that concept is okay with you. Now let's move on to polynomial division where there will be a remainder. We said no remainder, it's a factor, and that's key. So polynomial division where there's remainder. So take a shot at this, get this started, get this going. You might say, well, I know there's going to be a remainder of 2 because of that. Yeah, and there's going to be strategies here when you divide by a polynomial to know if it's indeed going to be a factor or not. It's not quite as clean, but there's a lot you can do. We'll learn some of them. In the old days, they used to make us learn dozens of them. But now, so I want you to get this started and see if you can find, there will be a remainder, see if you can find out what that remainder is and what's going on with that. Okay, let's look at some key parts here. So we did the same process, and yeah, the numbers are the same. It's really, really close. So some of you might remember writing R2, remainder 2. I don't know if you remember that. I've heard that in the past. It's better to say plus 2 over 5. There's the 5. Remainder 2 plus 2 over 5. So don't you think in terms of that? Maybe this jogs your memory. I'm hoping it does. Because over here, you'll notice the values are the same, except I changed that last number. So then when you subtract, you get minus 10. And I didn't highlight the subtraction here. Should I do that? So let's be sure we highlight that subtraction so that you know you have to distribute that negative. So negative 3 minus 7 gives me negative 10. So instead of saying remainder 10, you say plus negative 10 over x plus 1. It's exactly the same parallel as what we did over here with this. And then notice 5 was not a factor because there was a remainder. And so now we know x plus 1 is not a factor because there was a remainder. Same idea. So this next slide says show that an expression is a factor of this. So you want to divide and show that there's no remainder. So the thing that's tricky about this, and I want to jog your memory from this, is notice it's a 4, 3. I need to insert a plus 0x squared. We need to be in descending order. If you don't do that, you're going to find yourself in trouble with not being able to combine like terms. So go ahead, try this one. I'm hoping nobody forgot to subtract and distribute that whole subtraction. So this is what happened. This is what I got. So now take a second. What's the multiplication statement that you can write? So notice there's a multiplication statement you can write. And indeed, if you left out that, let me just say, if you left out that 0x squared, you would have had a hard time with like terms down here. It would have gotten kind of messy in that little section. So anyway, I think we're at almost 10 minutes, so I think we're going to end this review video and we're going to do synthetic division. I know you guys love shortcuts, and synthetic division is a shortcut. So let's stop this now.